So this is the first video in the beginner's guide to Pygame in Python. So you will need to go to github.com, Programming Rainbow, Beginner's Guide to Pygame. You'll need to copy that URL to clone it, and we'll use git clone and that whole URL at https://github.com, Programming Rainbow, Beginner's Guide to Pygame. Oh, I've already got it. There we go. Oh. Destination path beginner's guide already exists. There we go. Must have been spelling it wrong. Yeah, I put a capital G in there instead of lowercase g. So we've cloned it. If you are are on Linux, you're going to use something like Pacman -s and Python Pygame. Sorry, as with sudo privileges. But I already have this installed, so I am not going to install it. Looks like maybe there is an update, resolve dependencies. But anyway, I already have this installed, so I'm not going to be installing it. And we are just going to go inside of Beginner's Guide to Python. And in this folder, we have our fonts, images, music, and sound. This is the assets that we'll be using in this project. We also have the source code for video 1, 2, 3, 4, and 5. And we have the code that is there already is actually the code from video 5. So I'm just going to run the code really quick just to show you what the project will look like. Or we can just load that code. Make it bigger. And we'll run it with Python and it's main.py. Okay.
Pygame.
And we have the text moving around the screen. We have music playing, but I paused it. And every time I press the space bar, it says Python and changes the color. So that's kind of all the types of things that you would need to start building a game with. Now, I'm going to not use this. We're going to start from scratch, but I am going to just copy these couple lines up here so I don't need to write them all. So I'm just going to yank those, and then I'm going to get rid of this file. And I'm just going to create a new one that is empty called main.py. Okay. So the reason for these is if you are using VS Code, you will get warnings if you don't document every one of your modules, every one of your classes, every one of your functions. If you don't put comments in there, it's going to give you this warning. So I'm disabling those warnings, and that's for people in VS Code. That doesn't affect NeoVim. It's for people using Pylint, rather. And there is also a kind of a false positive. It's to do with Python and the way the Pygame module is loaded and stuff. It's going to give you an error, but you can safely ignore it. So I am disabling this no member error. And again, this one's for Pylint, but there is a similar thing that I'm using Pyrite down here in NeoVim, and I have to do a similar but different thing for Pyrite when I'm loading Pygame 0. So let's look at Pygame, or not Pygame 0, sorry, we're in Pygame. So Pygame website automatically takes you to their news, but we're really interested in the docs. So we're going to go to docs, and there is some nice examples here of code, and they're using local or global variables. So we will be building a simple class instead to hold our variables, all of our data and our logic together in a simple class. But it's not going to be a complicated class or anything. It's just going to be quite simple. So there is lots of examples here. We You can read through these. I'm not going to cover them. I'm just going to we're going to be building something very similar to this, but in class form. But I'm going to be explaining each part of it and what each function and method does and where I got it from. So the very first thing we need to do is import Pygame right here. So we have to make sure in our code that we're importing Pygame. And I'm going to import Pygame as PG. Like this. This allows me to, instead of using the Pygame word over and over again, it allows me to just write PG. It's a little bit simpler. But you don't have to do this. You can just import Pygame, but I'm going to import it as PG, so I can just use PG. And you'll see that I'm getting a warning that it's not used, but I'm getting another one as well. Let's see if I can pull it up here. So we're not accessing it. That's fine. But it's this one here, this third one, cannot find implementation or library stub for module. This kind of this is fine for us. We can safely ignore this. We can't do anything about it. But this is the same thing as this kind of member thing. It's the LSP is not able to understand what this library is and how it's loading correctly. But for our purposes, this is a false positive, so I'm going to put something on to ignore this. What I'm going to do is just put 2 spaces after it and a hash, and I'm going to put type ignore. And that's going to allow my Pywrite to ignore this. Okay, there we go. So yeah, we're not using it yet, but that's fine. So now we need to, before we use it, we need to initialize Pygame, and then also we need to be able to shut it down. So if we're in this docs here, right over here, there's just Pygame. So all of these are kind of the different classes or modules that are inside of Pygame. So we just need to look at the Pygame one right now, and that I already have that in a tab open right here. And we have 2 interesting ones, which is Pygame init and Pygame quit. So Pygame init, we don't need to pass anything. It's just initializing all the imported Pygame modules. So that gets it up and running. And to shut it down, we use Pygame quit. So let's just use both of those real quick. And again, I'm not going to use Pygame. I'm going to use PG for this. So it'll be PG init like that. And then PG dot quit like that. So that starts up Pygame and shuts down Pygame. Okay, so now let's talk about, like I said, I didn't want to use global variables. I will use global constants just to set a couple things up, but I'm not going to use global variables, things that are going to be mutated, because if I need to mutate them, when I define a function, I have to pass that, I have to pass global and the name of the variable I'm mutating into that. And you're not supposed to be doing that. You're not supposed to be using global variables. And I think both LSPs will warn me about this and tell me this is not good practice. I shouldn't be doing this. So I'm not going to do that. I'm going to instead make a class. So it's just going to be a simple class. I'm going to say class game. And we need an initializer, or whatever it's called in Python, an initializer or a constructor. I'll put the self in there. Okay, so we do need to get a hold of a screen that we can draw on, and we would like to actually change the title name. So let's look first at the screen. And what this is we're still here in the, no, not in this one. We're going to be in the display module, and I already have it opened over here. So if we click on display, and we want to set the mode, that's going to give us width, the ability to set width and height. And you'll see all this kind of stuff if you're looking in the, it's going to look similar to what they're doing here. It won't necessarily be the exact same every time, but see, they're initializing Pygame. They're having a global variable to the display, to the screen, and they have this clock. These are all global variables we won't be doing, but we will be doing similar things. So we're kind of looking at this one right here that's setting the width and the height of the screen. And I have Pygame quit down here. So yeah, so in display, we have set mode right here. I'm just clicking on it. It's going to go further down the page. I do have to scroll up a little bit each time because the way this page is displayed, it's blocking. So what this does is it allows us to define different options for the mode, but the only one I'm really interested in is the width and the height, this tuple right here. And this actually returns a surface. So this game display returns a surface, but it's like the game surface. So it's giving us a local variable that's holding our game surface. It's I believe it's like the renderer. They're calling it a surface, and it's held in a variable called screen, but I think of it as a renderer. It's either way. If it was software, it would be a surface. If it's hardware, it's a renderer, but it's here nor there. And this is Python wrapper around SDL2, and SDL2, this would be a renderer. And so that's what it really is under the hood. So this is returning a surface, and we're going to call it screen. So it's in our class, so we're going to call it self screen equals, and then it's going to be PG display, and then that set mode. And now in these parentheses, we need to put another set of parentheses inside because that's for our width and our height. And I want to put the width and the height, but I don't want to just put magic numbers in here. So what I'm going to do is I'm going to, above the game class, I'm going to create some global constants. So I'm just going to make some width, $600, and a title for the screen, for the floating window title or caption or whatever you want to call it. And I'm also going to put the target FPS. So these are going to be all the global constants that we're going to use for the entire series. So this is going to be our target frame rate. 60 frames a second is what we're going to strive for. So in here, instead of putting 800 and 600, now I can put width and height. This is not spelled right. Width and height, yeah. So I'm not doing this for variable purpose. I'm just doing it so I can, if I need to change the width and the height, if I want to make a game with a bigger one, or if I need to change the title, or if I want to change the frame rate, I can just grab them here and change them right here. But these are never used as variables. These are just used as constants. So I'm never going to mutate them. And if we want to set the caption, the what will be displayed, say when you open it up in Windows, how the very top of the window has a name on it, that's the caption, it's called here. And I use this title. So let's look at that real quick. That's also in display. So the Pygame display set caption is what we're looking for. And this one, I got to scroll up again because it always hides it up above there. But this is just taking the title, and that's the other one is optional. So that's all we're doing with this. So we're just calling this one directly. So it's PG display set caption. And this one we just need, I would put a string in here, but we already have the string here, so we can just put that in. So that's going to give us a screen with the width and height that we want. And we have access to the screen variable here. And we can also set a name for it. I'm going to set up a skeleton for a couple kind of what the class will look like. We're going to have an input. We're going to have a draw. We're going to have an input, an update, and a draw. That's kind of what the whole skeleton of this class will look like, the main parts of it, and then a run. So the run will be a loop that's just calling input, update, draw, input, update, draw. So I'm going to just define these methods real quick. And I'll just put pass in them for now, just so that they can work. You know, they're not doing anything, but it's not going to error on me. And this is going to be the main one that gets run. Okay, so this is kind of the basics that our class is going to look like. So we're going to be checking input, we're going to be updating our game, and we're going to be drawing our game. So right in this video, we have nothing that's going to be updating anything. So this update is going to be left alone. We do need to check for a close, if a close request has happened, because Pygame doesn't automatically close Pygame down. If you've asked it to close the window, it's not going to do that. It's just like SDL. You actually need to check the events that have happened and then tell it to shut down. So we do need to deal with input, and we do need to draw. So let's deal with the drawing one first. So we have this surface right here, the self.screen, which is a surface. And the way that we can blank this out every time is we could use a method on the surface called fill. So I had a tough time before. I couldn't find the fill, and I was thinking fill was on display, but actually that display was returning a surface. So if we were up here on the top again, we see surface here. So that screen is actually a type of surface. So in surface, we have an option that is fill. Okay, so if we click on this one, we can fill it with a color, and we can set other parameters. We only care about the color, so it'll fill the whole thing. But then there's the question of what are these colors? So if we go up to the top again, we get color, and I've already opened color over here. So we're in color now, and the color can be RGB, and it returns a color. That's fine. But there are actually named colors set. And if you look down here a little bit, it's kind of hidden down here, named colors. And I've opened that up over here. And we can just use these colors here if we wanted to as string input for fill. Any of these colors will do that you see here. So we can put an RGB from a 0 to 255 for RG and B colors, or we can just use a named color. So for this video, I'm going to use just a named color. And we could try, let's see, what's a nice color? I like this. Maybe this aquamarine 3. But we'll set it to black, but I just want to see this so we can see that it's working. So what we're going to do is we already have control of this self screen. This screen has already been populated. This is our surface, our thing that we're drawing to. So we're going to go into draw here. We're going to get rid of pass. And we can say self.screen and then .fill, because fill is a method on the surface class. And this is a surface. And now we can put in our named color. Oops, shouldn't have done that. Should do it like that. And that should work. Now that is drawing to the surface, but we're not going to see the surface. We actually need to, we need to display this now. So this is, if you think of this as the game, the palette that we're drawing to for the game, or the render, or the canvas that we're drawing on, whatever you want to call it. While we're drawing on it, we don't see it. We actually need to present it to the person. So in different engines, it's either called present, or it's display, or show, or all kinds of different things. So in Pygame, it's called flip. So if we go into display again, we have this display flip. I'm going to scroll up a little bit again. So this will update the contents of the entire display if your display mode is using the flag Pygame hardware surface or buffer. Well, we're not using Pygame 1. This will wait for the vertical sync. Okay. So basically what this does is you can think about this as you have two displays. One of them is a hidden display or a hidden canvas that you're painting on, and the other one is the canvas everybody sees. And then when you're done painting on the canvas that nobody can see, just you can see it, you're painting on it. When you're done, you can just flip them really quick all at once. So that's what this flip does. This flips the display so that now it's displayed to the person playing the game. If you've ever played really old games, some of the old games on the very old systems, you would actually see parts of the screen being drawn. And the last part of the game, like maybe the player sprite that was being drawn, that got drawn last, would actually be flashing because it would be on the screen for less time. And so that was not double buffered. So in this thing, that's not happening. All the drawing happens, you don't see any of it, and then they just flip the buffers all at once, and then you see everything at once. So we're using this flip. And this one is just a call directly, PG. This is not something on the surface. This is part of the Pygame display. So that will set our surface to Aquamarine 3, and then it will flip it so that we can see it. Okay, but we haven't done anything yet to, if we were to set this up and display it now, we would never be able to close it. And that would be a problem. So we need to think about checking to see if a close request or a quit request has happened. And that will be up here in the input. So color name. So if we go up here, it's going to be an event. There it is. And we can use this event get, Pygame event get. And I have to scroll up a little bit. And what this does is it returns the whole list of event queues that have happened. And there are different events listed here, somewhere on this page. Where is it? Okay, so here are some of the events, and we're interested in this episode, in this quit event. Basically, if you press the X to close the window or used, I don't know if it's Control-Alt-F4 or something in Windows, I'm not really sure. Whatever you use to tell the window that you're done playing it and you want to close it now, or you want to close the game, that actually sends an event that says, hey, they've asked you to quit this. And we need to capture that and then shut Pygame down. If we don't do that, when you go to click to close it, nothing actually happens. It doesn't close, and your operating system may say that your program is hung because because it knows that you asked to close it, but the program didn't close. So we need to make it ourselves. So what we're going to do is we're going to run a for loop on this event queue that we get back from event get. That's going to give us a queue of all the events, and we're going to run a for loop on it. And we're going to check each one of the events, the type of it. We're going to check the type. Let's see, event.type. We're going to check the type, and what we're looking for is the quit type. And we're going to do that in input. So like I said, this will be a for. So I'm going to say for, and I'm going to make my variable name just event. And it's pg event.get. So that's going to get all the events, and we're going to loop through each of them. We can just say if event.type equals, and it's pg, this is a Pygame constant, quit. So if it equals that, we want to do something. Now here's what we want to do. We would be having this loop down here, and then we'll tell that loop to close. So let's think about that for a second. I'm going to need something there and something here. We kind of have to build all of this at once from the ground up, but basically I want a game loop, and I'm going to put it in the run, and we need a variable for this so we know that we can tell it to close down. So I'm going to call this self.running, and I'm going to set it to true. So it's like the game is running. That's just a variable that I'm holding. And now down here, I'm going to tell this run game to loop forever until this self.running changes from true to false. So while self.running. So while this is true, I'm going to go through and do all the things. So I'm going to say self.input, and then self.update, self.draw. I probably have missed. No, I haven't. Okay. So this is going to run continuously. It's going to be checking input, checking, it's going to be running the code that's in input, running the code in update, running the code in draw, and then doing it again and again and again until this gets triggered. When this gets triggered, we want to set the self running to false. And what that will do is when a quit event has occurred, when you've asked to close the window, this will break out. Okay, so I want to get to us seeing the screen, but we have to build all of this to be able to see the screen. So nothing's going on in update. Let's see here. There's one more thing that I want to do before I do this, and I want to set the timing, because we want this game to run at 60 frames a second. So there is a way to do that, and they may even have it in here. I'm not sure. Yeah, they have this clock.ticks here, but they're creating this clock variable here, and they're using Pygame time clock. Yeah, we're going to do the same thing, but I'm not going to hold it in a variable because I'm only using it one time, so I'm just going to call it directly. So that is over here in time. If we open up the time module, I'm already on the page. I'm just looking for where is it? Pygame time. There it is, time. If you click on this one over here, time. The only one that we're interested in is the Pygame time.clock. And then inside a clock, there is tick, this specific one right here. And if I scroll up a little bit so I can see it, the interesting one about this is I can put in a frame rate that I want, and it's going to check how much time has passed in that one. Like this thing is looping over and over again, right? So imagine this takes a millisecond to check the inputs, all the events, and then it's done. Update takes, say, 0 milliseconds, and then draw takes 2 milliseconds. So 3 milliseconds have passed. But if I want to run my game at 60 frames a second, if I take 1000 divided by 60, I'm going to get 16.66, on forever, 16 and 2/3 milliseconds. So I need my game loop to take 16 and 2/3 milliseconds. So if only 3 milliseconds have passed, I need something to understand that 3 milliseconds have passed, and then to pause my game for the remainder amount of time, which would be 13.6 milliseconds longer, so it can stay on track for this 60 frames a second. So that's what we're doing here. This ticks, or not ticks, but just tick. This method should be called once per frame. It will compute how many milliseconds have passed since the previous call. If you pass an optional frame rate argument, the function will delay to keep the game running slower than the given ticks per second. This can be helpful by calling. So if we put 40 in there, it calls once per frame. The program will never run at more than 40 frames per second. Okay, so we already have our global constant that we created for FPS, so we're just going to use that. So this is Pygame time clock tick. That's what this holding is. So down here at the bottom of this loop, when it's done everything else, I'm going to say PG time clock, that's a capital, and tick. And then in the parentheses, I'm going to put the, up here we have FPS set at 60. So I'm just going to put FPS here. And that should allow our game to run at 60. So it's not going to run your CPU up. It's going to just let it be as easy as possible as long as it's just running 60 frames a second. So that should be everything that we need to display this. Now this is a class. We haven't instanced this class yet. So down here, we could say game equals, and we can make the instance of the class, right? Game like that. And then we could say game dot run like that. And that should work. So let's try that. What did I do here? Argument of type. Oh, this clock right here is a function call. It's a method. And do we have any others? We do have some. This right here is a missing colon. Right at this end of this if statement, I have a missing colon. And I don't have any other. Okay. So to run this, we're going to run Python and then main.py. And we did get the color that we chose there. I am going to change this to black, but I just wanted to put it at this color just so you could see that it was doing the thing that we hoped it would do. And if I press escape, nothing happens because I haven't set anything up to check escape. But if I tell it to close, it did close. So it is correctly working. Now let me show you something with this. We don't need to do this right here. So this is the class. So we're running the class constructor, and we're holding the instance of the class here, this game, and then we're telling the game to run its method, its run method, which is here, which runs all the other good stuff and times itself. But we don't need to really do that. We could do this, just like we did with the clock up here, how we had that, we could just do this. And that'll work too. Since we're only using the game one time, we're instancing it and running it immediately, and we're never using it again, we could just do that. And that works as well. Now, since we've put this shebang up top here, now I don't know if this works in Windows at all, but in Linux, you could put the path to Python here, or for this env is basically saying to run Python wherever it is. This means I can actually make this a self-launchable. I don't need to say Python. But to do this, I need this to be executable. So let's look here. If we look at this, in Linux, X is executable. For a directory, it already has X because it's a directory. But for a file, this file is read, write, read, read. That's read, write for the owner and read for other people. But we want it to be executable. If we make it executable, we can call it directly. Because if I try to do this right now, main.py, it's going to be like, I don't know what you're talking about. So this, again, is on Linux and possibly works on Mac too, because the Unix commands are similar. But I could say chmod. I'm changing the attributes, and I can add an X to it. So I say plus X, it makes this executable. Now if I look at it again, I have this. This is RX now, RX and X. It's executable. And the reason why I'm seeing all this is actually my ls. Sorry. Come on now. There we go. My ls is actually ls minus L. So if your ls looks simpler than mine, you need to use ls minus L to get the long list. But now I can run it like that. Main.py, and it runs. I don't need to say Python in front of it because it knows it's a Python script. So it just runs. So it's self-executable now. Okay, so let's just cover from top to bottom again. So that you don't need this here. That was just for me. Like I said, if you want to make it self-executable, this is called the shebang, and you can have it user bin Python or however it works in your system. It's not necessary to this. These down here, these pylint ones, these are needed if you're running VS Code and you want to get rid of the unnecessary warnings and also this false positive when you import Pygame, and it's gonna probably have it some other places here. For PyWrite, which is what I'm using, I have to use this type ignore here to get rid of that same false positive. Besides that, like I said, these are optional, and this top one, you don't need them at all. But here we're loading Pygame, and we're loading it as PG just so we can just write PG instead of Pygame every time. And we're initializing it here, we're shutting it down here, and we have some global constants here. We're creating our game class, and this is holding on to our render slash screen slash surface, game surface, whatever you want to call it. And we're setting the width and the height here. We're setting the caption here. This is just a variable to let us know when we want to shut the game down or not, or shut the game loop down. And here we're grabbing the events, the PG event get, and we're running through all the events, each one called event, checking the type of it to see if it's quit. If it is, we're setting our running state to false. Nothing's happening in update. In draw, we are using this fill, and I'll change it to, I'll show you that you can use, we could also say 255.255.255, and this will give us white. This is red, green, and blue, and this is between 0 and 255. That's the range that these colors could be. So 000 is black, 255, 255, 255 is white. If I wanted bright red, it would be 25500. You get the idea? And then after we're done all of our drawing, after we've everything that we need to draw, at the very end, we need to flip the display. So if we were running a whole bunch of other stuff, drawing other sprites and text and everything else, at the very bottom would need to be this PG display flip. And here is our where we call everything. It's just a infinite loop until this self-running gets set to false. And every time it's checking input, it's updating, it's drawing, and then it's making sure that we're on time to hit 60 frames a second. So it won't speed the game up, but what it's doing is it's slowing the game down. Because it might be like 300 frames a second and 9,000 or something, or running between 100 and 500 and going all over the place, but we want it to actually just be locked down to 60. And that's what this will do. And that's the whole class created, and this is to actually instance that class and use it, which is game. This gets us the game instance. It runs the constructor, gets us an instance of it, and this runs it. It calls this method right here, this run method. And once that exits out, it's going to run Pygame quit and shut down. So that should be everything for the video. So I hope you enjoyed. Thanks for watching. Thanks again. Bye.